At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Today's session is Simio for DDMRP design. My name is Dan Vasilini. I'm the VP of Global Sales over here at Simio. Doing most of the talking today, though, is going to be Christine Watson. She is a senior solution specialist here at Simio. A few things before we get started today. Just be aware, today's session is being recorded for replay purposes. If you'd like to rewatch this session or refer it on to a colleague or someone else in your organization to watch, that we will have this session up for replay purposes on simio.com. Normally we get it up there in about 24 hours after we're done, so be on the lookout for something within the next day or so if you are looking to go back and watch this. Also be alert, all participants will be on mute when you come in. If you'd like to ask a question during today's session, somewhere on your screen, on my side of the screen, it's the right side, there should be a GoToWebinar dashboard. Inside of that dashboard, there is a question area. In that question area, you can simply hit the drop-down button and type your question in there. Those questions pop up in front of me, and I will get those questions addressed when they come in. Normally, what we try to do is if the question is relevant or pertinent to the topic that's being talked about at that point in time, I'll try to interrupt it at an opportune time and ask the question. If the question is more generic in nature and can be addressed at the end, we will hold the question for the end. Now, I do want to give an alert. Today's session is scheduled for 60 minutes. Christine is packed full of information today. She probably has about 50 minutes or so worth of a presentation. So depending on how quickly I shut up is going to depend on how much time we have at the end for questions. So just be aware, if you do have questions during today's session and we don't get to them, there will be the ability to reach out and ask us those questions. I will flash my email and Christine's email again at the end of today's session, just in case you do have a question and it doesn't get addressed, you can reach out to one of us directly. Next, this is it for 2023. This is our last session. So before I let Christine get into this, I did want to thank everyone that has attended live this year as well as watched the recordings. We've had thousands of people that have attended and watched these recordings both live and on recording, so we do appreciate all of your participation and attendance. We do look forward to doing this again next year. We will probably try to keep a similar type schedule once a month. We did some experimenting here at the end of the year by holding these sessions on Wednesday versus Fridays. So we will go into next year with some eyes wide open as far as what worked out best and what we had the best live attendance for. And we're also going to reach out from a survey perspective with any type of suggestions you may have. If you did or did not see the QR code at the top of some of my slides or at the bottom of the slides, that is a survey we'd like to get addressed, some questions in there based on what I just stated as far as, time of day, day of the week, topics, things like that. So I would appreciate if you are watching this live or if you are watching this on recording, please scan the QR code and go in and go through our survey. Any type of information you can provide us is valuable. So do not think that your information is not being looked at, because it definitely gets looked at when it comes in. So please feel free to scan that QR code and reach out to us and let us know what you think. All right, so once again, there's the QR code. I'll flash that again once at the end, as well as mine and Christine's email. But without further ado, Christine, I'm going to turn things over to you, and I'll let you get into it. I know Christine has about maybe, let's say, 10 minutes worth of PowerPoint and another 40 minutes or so worth of demonstration. So Be prepared to just see a little bit of PowerPoint at the beginning and a whole bunch of demonstration after that. Once again, thanks for attending, and Christine, the presentation is yours.
Well, thank you, everybody, and appreciate everyone being here. As Dan mentioned, we are in the November Simio Solution Series, which is going to talk about demand-driven MRP. And we'll go through, first of all, just a kind of an agenda. What is DDMRP? We'll talk a little bit about that. Some of the features in Simio, how to calculate buffer zones, which is a feature of DDMRP, a brief intro to the example, and that'll all be in slides, and then we'll go spend most of the time in the model walkthrough. So here we go. What is DDMRP? Well, the concept of demand-driven material requirements planning was introduced by Carol Patak and Chad Smith in a book called Demand-Driven Material Requirements Planning. They're on version 3 now. And they also founded the Demand-Driven Institute, which basically helps to advance the DDMRP strategies in the global community. So they provide things like training, which some of us at Simio have gone through, software and personal certifications, and Simio has gone through and been certified by that Demand-Driven Institute for DDMRP projects. So what is it? It's basically, we're looking at the strategic positioning and sizing of decoupled buffer stocks, so holding stock buffers at different points in the system, basically to manage customer lead times and reduce this impact of variability both at the demand end and the supply end to improve flow. So basically the essence of any business is all about flow. Flow of materials and services from things like suppliers, maybe through multiple manufacturing plants, and then into your delivery channels, DCs, and so on to customers. And so that flow of information, what's planned and what's required, what's happening in the system, what should happen next. It could be the flow of cash back from the market and to and through the suppliers and factories. And basically the businesses have to take the materials that they have and convert or assemble those into different products or offerings, and then get those products and offerings out to the point where people are willing to pay for them for the most part. And so the faster the business can do that, it can either make or move and deliver those products, the better the performance of the organization tends to be. So to that end, DDI and the founders basically developed this innovative methodology called demand-driven MRP to manage the flow of material and information more effectively. And we'll see as we move into the software, it's visual, it's a practical way to support basically our new world of today since for the last number of years, where we're, as customers, we expect larger product variety, smaller orders with shorter lead times. We want to order things and have them delivered yesterday, and rapidly changing demand basically, and as well as supply chain conditions. And so that's what we'll talk about as we move forward. What are some of the DDMRP features added to Simio? Well, we have a DDMRP or demand-driven MRP replenishment option on the inventory element. We'll talk about that. We have 4 new DDMRP calculators that allow us to calculate average daily usage, decoupled lead times, buffer zone sizes associated with those strategic buffers, and qualified spike demand. So I'll get into a lot more detail in all of this in a few minutes. We have DDMRP specific dashboards that have been created, as well as a table schema for inputs and outputs to support the calculators and the simulation. And we'll go through these various tables and how they kind of come into play with all of the calculators. So an overview of the functionality in DDMRP within Simio. First of all, we have data table structures. Everything is demand or is data driven, data generated, and data table structures that will allow us to specify all the information and basically pull in information from our planning systems to run the simulation. There are objects in this top center area that allow, that have a predefined set of basically customized objects for supply chain modeling. Things like physical sites in the supply chain, as well as transportation, and to be able to deliver those different supply orders. And of course, the calculators, and we'll see how those work. Then when it comes to the supply chain simulation, on the bottom half, we've got the demand-driven replenishment policies. And that allows us information. We can look at kind of what's our net flow position, and we'll talk about how that's calculated, and allows us to determine when to order and how much to order of the various buffered items. And then we've got our adaptive process digital twin is basically our collection of the warehouse, factory, suppliers, any delivery related objects, sourcing policies, decision logic, and we can simulate all of that information in addition with those specific buffered areas and come up with a number of simulation results. So what supply orders are generated? What are the production schedules within the manufacturing areas? Delivery schedules, when do we expect to deliver product to DCs? And lots of KPIs. Now, these buffer sizes that we talked about, or that I mentioned, there are 3 zones. There's a green zone, yellow, and then a red zone that's broken up into a safety and a base, and we'll talk a little bit more about those. Here's just some of the information related, kind of the acronyms that we use for within those zones. So average daily usage, we'll calculate that. We can calculate decoupled lead time. We have input for minimum order quantities if you have specific order quantities that, you know, for given products, and then some variability in lead time factors. And within the DDMRP books, as well as the DDI Institute and their website, you can find information about things like the lead times. How do you determine whether to use a long, medium, or short lead time factors? And those come into play in the calculations. So the green zone is basically our order generation frequency and size. So when a product that is buffered, when the net flow, and we'll talk a little bit more as we get through here, when it goes into the yellow zone, we order back up to the top of green. So that allows us the order frequency and size, and we calculate that green zone basically based on a maximum of minimum order quantity, or if you have an order cycle, that times the daily usage, or a calculated average daily usage times the decoupled lead time, so the lead time for that product, and a lead time factor as well, which comes from here. The heart of the demand coverage is the yellow zone. So you'll see kind of our on hand is going to stay in that general area, and that's calculated again using the ADU and the decoupled lead time. And then we've got our red zone, safety and base, that are basically the embedded safety in the buffer. And of course, all of these calculations have a big impact on how those zones, how big or small those zones are. So the base is similar, ADU and decoupled lead time comes into play, as well as a lead time factor. And then you've got the variability factor that impacts the red zone safety. And together, those two things make the entire red zone. And I think one of the big things to keep in mind here is that it's very dynamic in that we're going to be able to calculate on a daily basis what those green, yellow, and red zone sizes are, and be able to react to what's going on in the system. And the simulation of Simio actually provides us a lot of additional information with that, because we're dynamically simulating forward or scheduling forward in time. And so what's going on in the system is going to impact how things are ordered and when they're ordered. You'll see it's also very visual, and we'll see that in the software. And then finally, we've got some adjustment factors that we'll talk about, so we can adjust based on conditions in the system, failures, excess demand, for promotions and things through what we call these adjustment factors. So a couple quick slides on the model description, and then we'll get into the software. Okay, so in this example, we're going to have a single supplier that provides information or provides materials to our factory and associated warehouse. We have a finished good and a couple subcomponents and some raw materials. And these we can see are our strategic buffers that we're going to keep of those various materials. And then from the lead times that we have, we can calculate our decoupled lead times, and customers are going to order directly from that warehouse. So we've got some firm orders and expected demand as time moves forward. So we've got sales orders that are coming into the system that will ship directly from the warehouse. When those things ship, we can keep track of on a daily basis what our on-hand inventory and net flow is. And from that, when our inventory goes below that green zone into the yellow and dips down, we are going to create manufacturing orders for the factory. We can, as we simulate forward, we've got a factory schedule. We can look at the Gants and so on. And then we also, when the raw material does the same thing, goes into out of that green zone and falls into the yellow, we create purchase orders that are sent to the suppliers. Now, a quick look at what the product structure that we're going to be talking about is we've got two finished goods, finished good A and B. Those have to come together, a final assembly and a paint of either A or B, and these are purchase parts, the paint. And the final assembly is made up of a subcomponent 1 and 2, and each of those has their own purchase part subcomponent or raw material as well. Now, in the top left here, we have in a circle the lead time for that product. So if I had a final assembly and the paint associated, I could make a finished good A or a finished good B in about 2 days. And the same thing, or an order of that type. Same thing with the final assembly. If I had the subcomponents, then my lead time is a day to assemble that final assembly. Quick routing, and then we'll get right into the software. We've got our subcomponents go through cut and drill. Subcomponent 2 goes through bend and weld. Of course, the pipe and sheet metal have to be available for that to start. Same thing here, we've got an assembly, final assembly that goes through assemble before it's available to be then moved into the finished good processing of paint with its associated paint colors, and then into the oven and in our finished goods. So let me go into, we're going to spend the rest of our time in the software here. And let's go. Okay. Oh.
Multiple screen
Try
issues.
that again. Sorry about that.
That's no problem.
Okay.
We can see it now.
There we go. All right. So where we are here, we're at the DDMRP one plant example. So this is a small version of a DDMRP example that's been released with the software. We'll talk. We'll take a look at that right at the end as we move forward. So we can see our factory. We store our materials within the warehouse. Subcomponent 1 and 2, you can see their routings. They go through cut and drill, bend, weld, one of the 2 weld machines. We can look over here. We've got our final assembly routing that goes through assembly, and our finished goods go through paint and into the oven. And if we looked at kind of our overview, you could see there's a supplier over here and a raw material truck. So if I was to go, I'm just going to run interactively for just a minute, and then we'll spend time looking at the data tables. So you can see we've got some initial inventory in stock. Over in the graphs, we can see our inventory moving down and then coming back up when our truck appeared and delivers some raw materials. And if I just pause it for a minute, you can see hovering over anything, some of our subcomponents that are being processed, the quantity of the order that's being processed, and information about some buffer status as well. So just fast forward through there. And remember that this digital twin model is a data-driven, data-generated model. And so if I go into the data tables, one kind of note is we will get into some detailed technical information at times. I know many of you on the webinar are Simio users, and so there are going to be some times we'll kind of get into a quick bit of weeds in terms of the technical detail here. Just to give you an idea of how everything fits together. But we'll try to stay on the top level. We started out this example and the DDMRP example with an ISA 95 product-based routing template. So new from template under the file. And what that provided was a data structure for tables like our resources, routing destinations, materials, routings, bill of materials, and manufacturing orders, which are now sales orders. So we'll talk a little bit more about that. So the resources table is actually generating the, based on the X and Z locations, generating the particular types of objects. So we've got the scheduling servers that can be modified. We've got an entry transfer node where all of our manufacturing orders come in and get some assignments, and then a supplier source as well, so that our supplier is listed here as well. And so this table is data, but it also generates the objects in the facility window. And of course, we've got our materials, our couple of finished goods, our subcomponents, and our raw materials. And we have the option of specifying those to be infinite if we want. And for the raw materials, there's information about what supplier they would come from as well. Just that's in here, we also have some lot sizing, and we're going to not get into too much detail with that. The routings, pretty typical of our standard format. We've got routings for each one of the different materials. The key difference here is that they're inventory based, and what that provides us is the capability to have the same materials like finished good A and B manufactured at different warehouses, and the process times might be slightly different, or maybe the routing is slightly different, and so these routings are inventory based, including the material as well as the site. And of course, the bill of materials is a related table that allows us to specify what materials go into a particular part. So you can see here, we're going to consume a final assembly and a paint A before processing, and then at the end, our finished good A is going to be produced for that particular, those couple of steps that are there. Now, the manufacturing orders that is typically within that ISA 95 template is now called sales orders, and we are actually going to generate the manufacturing orders. Those you can see here are an output table, and we'll talk a lot more about that in just a bit. Now, we talked about those green, yellow, and red zones for decoupled materials, and so the sales order assumes that it's going to just basically pull materials from those zones or from those buffers. And so we're basically just shipping a given quantity of finished goods from using this table. And if I look kind of down to the right here, we've got a lot of other tables that are here. You can specify employees, their schedules, qualifications. We have vehicles in this example. So we've got our raw material truck, resource calendars and exceptions. So we're not going to cover a whole lot of those in details. We don't have any employees in this small, simple example. But I do want to spend a lot of time talking about the DDMRP related tables and the calculators, and we'll then go through some examples. So we've got, as an example, a site table, and that is the location of whether it's a DC or a warehouse associated with a factory. You can specify any number of those here, and that generates an actual site object. So this is new, it's a new object, it's with the DDMRP examples, but not in the manufacturer, the ISA 95. So, and we'll talk about how that basically works. The inventories table is not new to Simio. The concept of the inventories element has been around for a long time, and that's basically our material and our site object combination. And what is new is this replenishment policy. So this is one of the properties within the inventories element. And we now have, in addition to our min max, order up to, a demand driven MRP policy here. And if I looked into real quick into the definitions, that table is actually generating all of the inventory elements. I have one here that we can just kind of take a peek at. And the demand-driven MRP replenishment policy then, when you have that specified, requires things like our red, yellow, green zone size and qualified spike demand. And you certainly could put in static numbers into this, but what the objective is that we're going to use time index tables. So we'll be doing a daily review, and we're going to feed data into these properties from time-based buffer zone sizes, and we'll talk about how that all works. Now, in addition to the inventories, and we'll come back into here and look at some of the additional properties that are specified within this table, but we have what's called our demand table, and that includes past and future demand for each material in the system. So that would include your finished goods as well as your components and purchase materials. And that's done on a daily basis. So what are you actually using in the past, any historical, and then any future demand as well. There's another table called the buffer zone sizes, or buffer profiles, excuse me, that allows us to specify for various lead time and variability categories what the factors are for those. So this table gives us the factors, and then the table is referenced within the inventories. It's a key column here in the inventories table. So our buffer profile key, and that enables us to just simply change these and see what kind of an impact these various factors have. And of course you can add, we've got some basis ones here for purchased and manufacturing distributed materials, and you can add your own as well. Now, there are 4 calculated tables based on the various parameters within the inventories table and the demand table and the buffer profiles. And that, first of all, is the average daily usage. And what that does is it takes past, future, or blended demand and calculates the average daily usage. And so it takes this demand table for each product and looks at, so some of the calculated information is coming from the inventories table. We've got a calculation type. In this case, they're blended, but they can be forward looking based on this demand table, or a certain number of days into the past. So we've got a horizon, how many days past are you looking, how many days forward, and you can even do some weighted things here. So we're looking at the 4 days past, 4 in the future. Past is weighted a little bit heavier than the forward. So some different calculations that you can do here, and those are calculated. And if we look up here at this DDMRP ribbon that's new, we've got 4 calculators that are basically set up to calculate these 4 tables here, and we'll go through how that works. We've also got our decoupled lead times. So Simio uses the lead times within the inventories table. So here we're back in inventories. We use the lead time. Now this would come from your MRP system or company's data in terms of the lead times, as well as whether it's a decoupling point. So are you going to use those strategic red, yellow, green buffers? And the product structure table, which is similar to the bill of materials, to determine the decoupled lead times. And what that does is basically provides us one of those. So we've got the ADU that's coming from here, our decoupled lead time that'll be calculated, and those several things together with our buffer profile information is going to be used with the buffer zone sizes calculator to come up with those red, yellow, and green zones. And this table provides that information. So again, the green zone is determining the, the order size and frequency. When we fall into the below the green zone, it orders up to a recommended order quantity, and we'll talk about how that does that. Simio does that automatically for us, and there's a log that we'll take a look at in just a few minutes. And then, of course, yellow is the heart of the demand coverage. And I lost my mouse here a minute. So we have our yellow zone and our red zone. Let's take a look quickly. How does this information get into the inventory element itself? So again, this inventories table is creating the inventories elements in the definitions. And the replenishment policy, because it's a property, but it has dynamic properties underneath it. So depending on which policy you use, you have different information that needs to be provided, whether it's the reorder point or the condition or those zone information. So if I come over here onto this right-hand side, we can look at how that buffer zone sizes table feeds into the element itself. So here we have the red zone size. So this is the property that we looked at a few minutes ago in that definitions of an inventory. It's pulling information on a daily basis into the buffer zone sizes, red zone size. That's our table, and then if I look here. So our red zone size from the buffer zone sizes based on the time indexed values. Same thing with yellow and green, and qualified spike demand is also time indexed as well. And of course, if you were to change from a demand-driven MRP replenishment policy, and I'll show an example of that, you would be requiring this other information for whether it's reorder point, order up to, and so all of that information is here and references various parts of the inventories table for those. Okay, and then finally, we've got our qualified spike demand table that looks at some parameters within the inventories table. So we're going to kind of move over here past those ADU parameters, and we have some spike zone parameters as well. So there's a threshold factor, some constant information that you can add to it if you want. But we look at, and this takes a look at half or 0.5 of the red zone. And what it is going to do is it looks at the sales orders, the quantities, and the due dates that are within that sales order to see if there's any large orders, and we'll take those into account ahead of time based on our timing factor, and print that and send those out to this qualified spike demand. And what that enables us to do is basically see any kind of upcoming spikes of large orders that are coming in, and we can manufacture those and take those into account. So again, these buffer zones are quite dynamic, and we'll see that in a few minutes. So first of all, I want to go ahead and go through the calculators in use and show a couple of examples to get the calculators activated. Now, if you're using one of these examples, whether it's this one or the DDMRP example that comes with the software, these will be activated already. But just to give you an idea of what is going on, if I go into our data connectors, you see under Create Importers, there are 4 new, and these are not importing data, but they're calculating data based on the data that we just talked about. So our average daily usage, buffer zone sizes, decoupled lead times, and qualified spike demand. So we have connectors for each of those. If I go back into these tables, you'll see that this is using the average daily usage calculator, and the name of the calculator also needs to match up with the name of the table. And so again, if you're using this, if you start out with an example template, which is typically what you would do, this won't be an issue, but it's good to know kind of some of the basis of how this is working. Also keep note here that our average daily usage, all of these are automatic at this point. And what that means is that if I am in planning or if I'm in an experiment, it is going to automatically calculate those. And I'm going to show some examples of actually going up here and changing some of the data and showing how the calculators work if I click on them. So a couple of use cases. I want to click on the buffer zone sizes for a minute. And remember back in the slides I talked about with the green zone, it takes the maximum value of your minimum order quantity or your, let's go and see. So the minimum order quantity is in the table here, or your desired order cycle times the ADU, or does a calculation of average daily usage, decoupled lead time, and then whatever lead time came from the buffer profiles. So this value could be different. And in this case, it's a 13. Sometimes it changes, and these are all finished good A's at this point, and then B's are down further. But if we look at, as an example, our green zone, and it's calculated right now to be a 13. If I went into my finished good A at warehouse 1, so it's this same product, and I changed the minimum order quantity to say 20, and if I run the buffers, or actually I will calculate all because it does them in these orders. So if I say calculate all, you'll see that the green zone size, because remember it was the maximum of those couple of calculations, now the minimum order quantity is larger than originally it was 13 or 14. And so if you have a specific minimum order quantity, it will adjust your green zone size accordingly. And if I go back and calculate all, it goes back to our 13 and 14. Same thing if I had a desired order cycle. Let's say I only wanted to order approximately every 3 days. And it's going to look at our average daily usage for that time period. So in this case, 8.3 or so times the 3. If we look back in our buffer zone sizes and we calculate, you'll see it updates all of those based on the daily ADU and this desired order cycle. So the green zone has a couple of things that it's possibly looking at in terms of how those values are calculated. Now, if we were to change a buffer profile as an example, we can look, right now we're doing a manufactured short lead time, and if I'm going to just look here, so we have MSL, short lead time and low variability. That is the key factor here. If I come down and I change this to a manufactured short and high variability, that variability factor actually comes into play with the red zone, that's safety. So for example, if our, let's say our suppliers are having some issues and so there's additional variability, then you want your safety to be higher, and we'll see how that impacts this. So if I change that for that first product again and calculate all, you could see that the green zone changed to be a bit higher than it was in that original. So if I go back to the MSL and recalculate, it was originally 17, then bumped up to like 24, 25. So it made that red zone bigger. So I'm just kind of going through some math, and what we'll see in a few minutes is we'll look at the graphics. That's, you know, the dashboards that are generated from this. One last one I want to show from a math standpoint is the decoupling point. So let's say that our final assembly was not decoupled, and so we're not keeping a demand-driven, you know, the red, yellow, and green zones for that. Maybe it's a min-max, and we have some data that's in here for that. And we would come and say that this is no longer a decoupling point that is DDMRP related. What that is actually going to do is it's going to take, remember that final assembly feeds into both of those two finished good products. And if I look at my decoupled lead times, originally, because there was a buffer, a strategic buffer of final assemblies, the decoupled lead times are just basically the process time or the lead time for that particular product. So finished good A and B were just 2 according to the lead times. Now I've undecoupled this, and so this 1 day of how long it takes to manufacture the final assembly is going to be recalculated into the decoupled lead time of those 2 finished good products. So if I was to do a decoupled lead times here, just to show you what that looks like, the final assembly is still taking a day because it's everything underneath it is decoupled, but the finished good A and finished good B are now 3. And so what kind of impact is that going to have? Well, that means that our final assembly, the product might not be there. We don't have those decoupled strategic buffers necessarily there. And so the finished good A and finished good B might take longer. So their lead times, their decoupled lead times are higher. And if we looked and I do our buffer zone sizes, you can see that decoupled lead time comes into play in all 3 of those zones. So from a math standpoint, it factors into all of that. And so again, just a couple of examples of some of the math behind some of the calculators and how those work. And we're going to show the how some of those factors work in the dashboards as well. Let me just recalculate everything so it goes back to the original when we start out. So what I want to do now is show our inventory, a quick look at our inventory review log. I'm going to go into planning and create the plan. And we're going to go into our log. One of the things that's new with that DDMRP inventory replenishment policy is the inventory review log. What is actually going on a daily basis is what our review is for each product in the system. We keep track of the quantity in stock, quantity in order, the qualified spike demand, and those all go into play when it comes to the net flow position. And that is what, when that net flow falls below the bottom of the green zone, there's a recommended order quantity, and it tells us how much do we order. And in this case, we can see that. So Simio is doing all of these calculations on a daily basis behind the scenes for us, which is great. And let me just, so one of the things to keep in mind is when we do have this recommended order quantity, within the data table, we've got an on replenishment order process. This is not new. It's been there with all of the other replenishment policies. And in this particular example, and with the DDMRP example, these processes are called when a replenishment order is recommended. So from that review log. So we've got one, the on inventory replenishment process for finished goods. We've got a manufacturer subcomponents for the manufactured, or for the subcomponents that are there, and then of course one for the raw materials. So for the finished goods, depending on the sites that you have and any sourcing that you have, it actually could generate what we call a stock transfer order. If you have a DC and there's no associated factory, but you're ordering from there, we might, within this logic in the processes, as well as logic that is within the site object. We might transfer material either from another site or generate a manufacturing order at that same location. Now, for the subcomponents, it generates a manufacturing order for the factory that's associated with it, and then the raw materials, it generates a purchase order. So inside the Simio engine, for that demand-driven MRP replenishment, it does that daily inventory. You see that in the inventory review log, determines the reorder point quantity, and then there's that token, which is, again, not new, but it's the token material order detail that's sent into these appropriate processes and creates those orders and then generates them. And so if I looked into our planning, and because that's where I ran it last in our tables, we can see we've got manufactured orders, and here's that 36 for that first recommended order quantity. If we looked at the logs and compared those, you'd see that. We also have, I just have the filter on, but you could see there's subcomponents in here, finished goods, and the purchase orders from the various types, paints, and so on are shown here. And if we were doing any kind of DC, we would see stock transfer orders here as well from a source to a particular destination. All right, I'm gonna try wrap this up, but the most important thing is the planning mode is where we have the dashboards and the Gants. Of course, Gants have been around a long time. You run the simulation and you can graphically see kind of a general idea of what's going on within the resources. But the most important thing here in our results is our dashboards. And of course, we can see how many are late, how many are on time. Those are based on the sales orders. But if I come into my dashboard reports, we have a number of dashboard reports. I'm just going to kind of expand these that allow us to dynamically see the system that's simple. These are visual. And as you can see, these based on the average daily usage and how that changes over time, these zones are not just kind of a static thing. They change based on the demand that you have. So we have, in this case, let me talk about a few of these. The buffer status planning, this gives us, so I'm going to just take a look at finished good A as an example. The black line here, again, is our net flow position. So when we drop into the yellow zone, we place an order for based on our recommended order quantity to the top of green. Now you see it won't always go to the top of green because, of course, constantly daily we're shipping out sales orders in this case as well. The blue area, or this blue line, is our on hand. So depending on the lead time, sometimes it'll be a kind of a shorter version of how that net flow and on hand are correlated. And then of course, if you look at something that's like a 5-day lead time, you can see, it takes a little while for our inventory to come back and get replenished from the suppliers. Let me show real quick if I look at my data table, one of the things that I had not shown is this planned adjustment factor. What this allows us to do is to, if you have a promotion, if you've got something going on in your system where you need to adjust these, so maybe you have a promotion of finished good A, and I'm just going to say from the 10th to the 25th, let's just even say the 20th, and we have adjustment factors that are come into play for any of these buffer zones. You can adjust the yellow zone if you had some preventive maintenance and you needed to kind of make that zone bigger. If you have additional variability, snowstorms, construction, you might adjust the red zone. Here we're going to adjust the demand, and that I'm going to come in here and just run the plan again. I'm going to look at our finished good A. That's where we had that. And you can see for those 10 days, starting around the 10th or so until the 20th. This is actually, let me just do it a little bit longer so we can see. You can see it adjusted this this zone size for the demand, and of course it adjusts the red and the yellow as well. So if you were looking at, do I have the capability to run a promotion, you can see what would actually happen over time. Again, these are simple to look at, and it's really amazing how the factors that are involved and some of the key things impact these various graphics. So if I look at some of the other dashboards that are very key, the planning screen is a great one to look at. It's a version of that inventory review log. It gives us our net flow, our order, what our order recommendation is, but it also provides us a couple of things like the planning priority, which is the net flow divided by the top of green, or the percent of red zone. So that looks at our on hand over the red zone percentage. These can actually either be statically or dynamically used as dispatching rules, which we do for determining what materials to process at a given resource. That's key. Like, we've got finished good A and B that are going to be both going to paint on occasion, and so perhaps we should use the lowest planning priority or the lowest percent in the red zone to make sure that finished good A, because it's in the red zone here, is processed before a finished good B at paint, as an example, as opposed to using a due date or some other kind of dispatching rule. There's also a buffer run chart that we can look at. You can see I'm not going to be covering every single one of these, but the buffer run chart gives us an idea based on the target where our on hand should be. If we're in the red on the top, that's a little too much inventory or a little too little inventory on the bottom. You want to stay kind of in that green area, maybe sometimes in the yellow. And there's inventory target ratios that are based on those values that we can see as well, and we can look at those target ratios both in units as well as dollars associated with those. We have, of course, you can look at your resource utilization summary. You can look at it on a daily basis. And if I go back into here, just a second. Okay, another key one is the inventory cost by material site. So we could look, this is just for warehouse one. If you had multiple warehouses, this is also very informative, and it gives us a total cost by material if we wanted to look at finished good A, as well as our weekly inventory costs, because when you're comparing those buffers and what impact some of those key measures have on the buffer sizes, of course you want to take a look at cost as well. Okay. And here we also, you'll be able to see the manufacturing order details. Information like this can be sent out from any of the dashboards, can be exported out, sent back to the systems that you have. And then of course we've got details for purchase orders, stock transfer orders if we had them, as well as a constraint Pareto that gives us an idea of where is our material, where are we being held up? Is it because of the transporter or the vehicles? Is it because we can't get into a particular destination, or are we having some kind of material availability? So all of these dashboards have been developed with DDMRP in mind, based on the book and the KPIs and the graphics that the DDI folks have come up with, and it really gives us a great dynamic look at everything. One last thing I want to mention is that we have, when you're in the process of implementing DDMRP, whether you're evaluating future demand forecasts, determining where to put decoupling points, adding new equipment, whatever it may be. We always have Simio experimentation that can be used to evaluate those KPIs that you have in your system under different operating parameters. So in this example, and I mentioned, if you have those 4 calculated tables set to automatic, the calculators actually run automatically between each one of the scenarios. This is because the calculators are new, that behavior is new here as well. And in this example, we've just set up our inventories table with a couple of different options. Our 20, some of these are ones that we've gone through, the 20 MOQ, the 3-day order frequency. If we don't decouple our final assembly, what kind of impact does that have? Just a couple of KPIs, whether it's the on-time orders, cost is a big one, utilization, and you could have as many of these as you wanted. And you can see that when we look at, for example, our cost, when we don't decouple that final assembly, remember that decoupled lead time was higher, our buffer zone sizes were higher, so we're carrying a lot more inventory in order to be able to react to those sales orders that are coming in. And if I look, just to give you a quick example, all of you should, if you have the latest software, we have our DDMRP example. And what I just went through is a very small 1-plant version of that, and even kind of a small example of that. And within the software, we have this DDMRP example. You saw I went to support, and then under examples, a couple of suppliers, multiple factories, as well as a distribution center. And if we watch that, you'll see we've got materials that are being transferred. There's no factory here, so any customer orders that come into the DC have to be transferred, and so there's some sourcing that's in here as well. It's a great example if you get a chance to take a look at it. And so basically the demand-driven MRP methodology and Simio together basically allows us to apply this methodology and to our adaptive process digital twin to be used for simulation, as we saw, scheduling, orchestration, from design to operate wherever you are. And it helps better model the process, whether it's manufacturing or supply chain, so that you can use this model, whether it's predictive or in a prescriptive way, depending on where you are as a customer in your journey for digital transformation. So I know I've talked for a long time, and haven't left too much time for questions. I appreciate everybody's attendance, and I guess we'll shoot over back to Dan for questions.
Perfect. Thank you, Christine. Nice job. And as you said, you ran right up to the 50 seconds until we ended this. But let's do this very quickly. So I've got on the screen both my email address and your email address. So if we don't get to your questions that are out there, because there are a nice handful of questions that came in, if we don't get to your questions, please feel free to reach out to one of us directly via those email addresses. So let me just go through maybe one or two real quick, just so at least we address one or two. First question was, how difficult would it be to build my model, or build a model of my factory?
Well, the great thing about using the template that we have set up, that's got the resources and routings and material master, basically the simulation scheduling type of things, as well as the DDMRP tables. If you use that and you populate a lot of that data from your whatever your planning system is, your ERP, that really can bring in about maybe 70 to 80% of a model, basically using those. And you can certainly add logic through our processes window, change a little bit of the logic that's in there, but that would get you a good ways in, I believe. Okay.
All right. And then there were multiple questions about data, so let me just read this one, and then for everyone that hung on, which we had a large majority of the folks that started live have stayed on live. So can this DDMRP model be connected to my enterprise data so that we can run it daily or weekly based on current state of the factory?
Yeah, that's the great thing about Simio is that you can use it from a simulation standpoint, but also we can connect directly to enterprise data, bring that data in and initialize the current state of the factory, and it can be very dynamic and help with your what if scenarios, or when you're planning things like promotions or new product introductions. Certainly this model could be used on a predictive or prescriptive kind of basis.
Great, great. All right, so since we are over time, I do want to thank everyone for attending live here today. If you are watching this on record, this last flash on the screen here includes my email address as well as Christine's, as well as the QR code to scan for a survey we'd like to get addressed if at all possible. And just to end up here, once again, this is our last session of 2023. We do thank everyone once again for attending this year. We look forward to seeing everyone again next year. Christine, thank you. We'll wrap up here. And if we didn't get to your question today, we do apologize. Please reach out to us and we'll get those addressed. Thanks, everyone.
Great.
Goodbye,
Thanks.
and have a good rest of your year. Bye-bye.